Moving on to the concept, wherein the agenda is to find the coordinates of a random point sitting on the parabola in terms of a real parameter t. So that as you keep on varying t over the set of all reals, you keep on obtaining the infinitely many points sitting on that parabola. Alright, so let's begin with the very first rightward opening standard parabola y square equals 4ax. Let p be some point sitting on it. Now my task is to find the parametric coordinates of point P. Basically, I want to write the coordinates of P in terms of this real parameter T. How will I do that? Let's use hidden trial method, okay? Suppose I take x as T, the x coordinate of P as T, then because P is lying on the parabola, it will satisfy the equation of the parabola, and hence the y coordinate will come out to be what? Under root 480. So, the parametric coordinates of P will be T comma under root 480. But you know what? I will not finalize this to be the parametric coordinates of point P because there are certain issues associated with this. What are they? First of all, this square root sign is really irritating because it is going to just make my calculations complicated. Secondly, because t is varying over the set of all reals, for negative values of t, 480 will be negative and under root of a negative quantity doesn't exist. That's why this doesn't work. Okay, x equals t doesn't work. Rather, let's try to write x in terms of t in such a manner that 4ax happens to be a perfect square. Because in that case, there will be no square root sign to irritate us. Cool. Now you can see 4 is already 2 square. A is single. So let me have x to be equal to a into something. So that a into a gives me a square. 1a should be there in x. Now a parameter should also be there. But I won't write it as t. I will rather write it as t square. Remember, I want perfect square. So when I take x as at square, my right hand side becomes 4a square t square. And hence y comes out to be 2at. Now you all would be wondering, why did I not write y equals plus minus 2at? But come on, use your common sense. T is varying over the set of all reals. It's taking both positive as well as negative values. Okay, so for t positive and negative, 2at will bring up to you all the plus minus values. All those will be taken care of because t is taking positive and negative values of the reals. Cool, that's why it's not important. It's not needed to write plus minus. Okay, bingo, what do I get? At square comma 2at to be the pretty looking parametric coordinates of point P sitting on the parabola y square equals 4ax. So you understood the strategy, how I obtained the parametric coordinates of this point sitting on this parabola, right? Now, the mind-boggling conclusion, or I should say the mind-boggling observation from here is that any point sitting on the parabola y square equals 4ax will definitely look like at square comma 2at for some real number t. Yes. Why? Because for every real value of t, at square comma 2at satisfy the equation of this parabola. Yes, try it out. Plug in y as 2at, you will get y square as 4a square t square. Plug in x as at square, you will get 4a square t square. They are same. For every real value of t, at square comma 2at are satisfying the equation of this parabola. That is why any random point you pick up on this parabola, it will look like at square comma 2at for some real t. Got it? Now that you've got the drill, what do you think should be the parametric coordinates of the point sitting on the leftward standard parabola, the leftward opening, y square equals minus 4ax. This time I am going to take x to be such that minus 4ax comes out to be a perfect square. So first of all, x should have one a, so that a into a gives me a square. It should also have a parameter. I'll write it as t square. Further, to take care of this minus sign, I will adjoin a minus sign here as well. So in here, I am taking x as minus at square because when I do that, I get y square equals 4a square t square, which gives me y as 2at again, and hence the parametric coordinates of any point sitting on this leftward opening standard parabola are described by minus at square comma 2at. That means any point you take on this parabola, it will look like minus at square comma 2at for some real t, because for every real value of t, these coordinates satisfy the equation of this parabola. Moving on to the next one. How will I describe the parametric coordinates of a point sitting on this standard upward opening parabola? Tell me. This time I will take y to be such that 4ay is a perfect square. So again, y should have 1a, so that a into a gives me a square. It should have a parameter, so I'll write it as t square, and bingo. When I take y as at square, x comes out to be 2at, so 2at comma at square happen to be the parametric coordinates of the point sitting on this particular upward opening standard parabola. Because again, for any real value of t, these coordinates satisfy the equation of the parabola. Got it? Lastly, again, I want to take y to be such that minus 4ay is a perfect square. Come on, tell me, what will I do? First of all, y should have 1a, so that a into a gives me a square. It should have parameter, which I will write as t square, not t, but t square. I want perfect square, okay. To take care of this minus sign, I'll join a minus sign here. When I take y as minus at square, x comes out to be 2at, and bingo, 2at comma minus at square again happen to describe the parametric coordinates of a point sitting on this downward opening standard parabola. Because again, for every real value of t, these coordinates satisfy the equation of this parabola. After we are done with parametric coordinates, the another terminology which is important and comes into picture over here itself is parametric equation. See, when individually I write x equals at square and y equals 2at, these two equations are called parametric equations of the standard rightward opening parabola y square equals 4ax. Further, when I write x equals minus at square and y equals 2at individually, these two equations describe the parametric equations of my leftward opening standard parabola y square equals minus 4ax. Similarly, x equals 2at and y equals at square describe the parametric equations of the standard upward opening parabola x square equals 4ay. Lastly, x equals 2at and y equals minus at square. These two equations happen to describe the parametric equations of my standard downward opening parabola x square equals minus 4ay. Got it?